Hey, my name is John Doyle. I'll walk you through our submission to the Postman API Hackathon. We decided to use Postman to help us analyze distributed systems, and we achieved this by building out our own API that takes in an endpoint and performs network tests in 16 AWS regions. In each of the regions, we perform NSLOOKUP, a whois query, and also a get operation on the endpoint. In addition, in 8 regions, we also perform a traceroute and also a dig query. All the data is then saved down to the region level and duplicated across the other 15 regions. As a consequence, when the user requests the test results, they get the complete data set. We then utilize the Postman visualizations to help us analyze this data and really pinpoint what information we are most interested in. So we're going to dive in to our actual project submission. So this is the global API network information. And if we scroll down, we can actually pull up our public workspace. So in the workspace, for instance, we have our collection, and we'll dive into that in a bit. We also have our API. The spec is built out for our currently published one. We have our environment set up. Not very many variables involved: the base URL, the network test ID, and an actual API key. And then the other thing we really use is the actual monitor. So we get notified when we make our own breaking changes to the test. So that's quite nice. So as you saw with the API key, we'll have to go back to our project submission. And if you go into app.apinetwork.info, we can actually create another account. So I'll set up a +2, I think, at gmail.com. I'll create this account, get our verification up, and our code is here. Throw that in. I really need to get a little bit more React information, but request our API key, refresh again, and we have now our API key. So I'm going to switch over to the desktop app now, and within here we're going to quickly update this with our new API key. And now we can actually look at what a standard network test is. So in this case, we're going to actually hit our demo API. So this is distributed across 4 regions. And apparently I've hit the limit. Oh. Post, JSON test, yeah. Why wouldn't that? Give it a few seconds as the API key is distributed across the network, maybe. Ah, that is it. One issue though we did run into was the fact that when an API key is created, it is for a specific region. And so we actually had to build another system that would distribute any one API key across the 16 regions and install them into each of them. So here we go. We have our API key, the time, and the test results will last for 48 hours. Most importantly, our test ID. Now our test script should have automatically now populated that this isn't one of the test scripts. So we'll just actually do this ourselves. Set that as our network test ID. And now as that goes, we'll actually call the test result here. And this is now just going to provide us the complete data set that we see. So we have all the dig information here, whois, it's response, get all this information, connection closed, and so on. And this is all by region. So you see here AP Northeast 1, and it'll go on and on. And as the commands complete, you can go back, request some more. So this is a 66.79. So let's see if we got any more. Yeah, you can see it keeps growing as we go until all the commands complete. Now, it's a lot of information though to try and analyze. And so we're going to actually try and see what we could use this with. So one example we have, for instance, is the latency. So we already have a request out there. So if we now execute this, we're again getting that same data back, but we can now utilize the visualization section to actually see how each of the regions is actually what type of delay they are seeing. And you can see Southeast Asia, SA East 1. They're still only seeing 1.4 seconds, but it's significantly higher than some of these other regions which are getting instant responses. You could also look at verifying API versions. So these are both based on the response, and the response includes, for instance, if we look back at the pretty, if we go down to one of the responses. So yeah, in the response, for instance, we do have, for instance, our latency. You can see our status code and so on. And what else? Oh yes, in our verifying API responses, we also have the option of passing a Jsonpath query. So I'll actually kick this off also. This is still hitting the same endpoint. But in this case, this endpoint specifically is just returning the version and the region if you hit that yourself. I'm sure we can do that right now. So if we hit this, we should see, yeah, so I've currently 1.10 and that routed me to EU South 1. Now if we go back here, now that we have this, our test results here are automatically populating our network test ID from this. So we can go straight to verifying API regions. Now, right now, everything should be the exact same region. We look at this, yes, it's showing green. All the regions are showing the exact same version ID. But if we go into the actual code here, and all it is doing is it is taking the version from the deployed package.json. Now, if we actually then deploy the new version, so this is in 4 regions, as I was saying, so it's going to iterate over them one at a time. So once we see it starting to hit that first region, we can fire off another round of tests. First, it's checking that there's no updates needed for any of the certifications. Now you can see that it's going to go after AF South 1, which I think is Cape Town. So we'll wait for this one just complete first before we kick off the request. Any minute now. Great. So now that that's done, we'll kick this off. And it's returned already, so we have our new test ID. It's confirming what JSON path that we provided. If we go back here again and run this, hopefully, yeah, we can see SAE1, it's red, showing that there is a discrepancy here and alerting you to the different changes. So that was a very interesting one that you can build into CI/CD pipelines that are around distributed networks, making sure that your update has been applied to all regions as users are hitting the application. Another one is trace cert. So for instance, we can pull back our data set and utilize D3 and so on within our test framework to map out, oh, maybe I should kick off a more interesting one. Or maybe not. There we go. Sorry. Again, the data, the commands were running. So you can see here now, for instance, that so we have this in Milan, Cape Town, though it looks like the lat long is a bit off, Hong Kong, and I can't remember which location this is. But you could dive in and actually see how these are being actually sent back and forth here. So that interesting little one that looks like Japan is actually being routed over to Cape Town, it looks like. But then we could do some very weird stuff also with this system. So there's the setting up a Sansky hops diagram. So this is again, just trying to utilize different visualizations. This one isn't very helpful because it's such a large amount of hops, like you can see here. Let's see, even if we start minimizing this a bit more, we can start getting a better idea of the complete hop list. You see some regions which are specified by the red box, showing that it is an AWS IP address. Sometimes they resolve directly to the endpoint. We'd expect this, for instance, in the regions that are, I guess, closest to the endpoints. Other ones, you can see the crazy hops that they're taking and so on. And the idea is that maybe you could not necessarily use this whole chart, but you could start building in the context of when it's hitting your network. We can also then export these type of charts, SVG01, and then within that we can obviously open up in whatever your SVG editor is. Though that definitely does not look any better. So beyond that, so that was the Sansky, who is again another example of looking at a comparison. So for instance, in this instance, the request would have been out to demo.apinetwork.info. So API Network was registered within AWS. So when we actually perform a lookup here now, we should be expecting that all the registered data is in sync. But yeah, as you can see here, the updates between AWS registers or their Whois databases, which seems to be like broken out into several regions, there are discrepancies in the number of their update timestamps. So this will obviously change if you run this later and so on. But like right now, they all agree on the actual data set. But we can say, like, if there were changes made to, the tech description or email contact information, it could propagate slowly, in which case you might want to look up here to see if it has fully been globally distributed. I think that's really all the stuff that we dived into. I should just go back and verify that all our API versions have been updated. And, obviously I have to kick off another request, since each request is time-bound. This off, yeah, everyone's updated to 1.2.0. Great. Well, I hope that was interesting for some folks. Cheers.